All right, aloha students. This lecture is on WebGIS and sharing GIS, I guess. And obviously GIS is a digital medium, so we share all these things to the internet, basically. I'm gonna try and make this relatively quick. I think everybody wants that. Okay, so sharing GIS, making a map in isolation is great, but when you can share it and when you can actually collaborate on it digitally, the power kind of multiplies. You all know this from your group projects, right? Having multiple people creating data, collecting data, processing it, it just really kind of multiplies what you're able to do, basically. And there's more complex ways to do that than just like sharing shape files and that kind of thing, right? You can actually share workflows, you can share scripts, you can share tools, you can share online resources and that kind of thing. So, we're kind of in the middle of this shift, basically. So when I was first learning GIS, it was all like a very desktop based model. You have a desktop computer, you have a license from like ArcGIS, like QGIS didn't even exist back then. You have like ArcGIS, and it would be locked to your local computer, and you just use that local computer, and everything goes there. You create something, a PDF of a map, an image of a map, and you send it off, basically. Now we're sort of changing, and we're moving more towards cloud computation, but we're not quite there yet. And so, like for instance, ArcGIS Online, or sorry, ArcGIS Pro is a good example in that. ArcGIS Pro uses your online account as kind of like the software lock, basically. So you could have ArcGIS Pro on a bunch of different computers, and as long as it's tied in with your one username through the internet, then you can kind of bounce around a little bit. There's a little bit more freedom there. But we're not quite to the point where like all of these things are happening on the internet. And obviously the pandemic kind of changed that a little bit so that you kind of have to do this, especially if you don't have the right kind of computer or it's not strong enough or that kind of thing. You have to use these online resources. But like that process is very much in its infancy right now and really not quite ready for prime time. That said, a lot of companies have done this and they've got, Linux servers set up and they run, QGIS tools and GDAL and all these open source tools to get away from the ArcGIS model and paying Esri a lot of money. But that sort of exists kind of in the corporate world a little bit and in some of the tech sectors, but like not a lot in research as much, although we're going that way and we're transitioning. So it's a good thing to know about. Just WebGIS and sharing GIS in general is a super hot topic right now. And if I was going to get into GIS right now, I would focus a lot on this kind of avenue because, like I said, we're in this transition, and so there's a need. You could imagine how something like WebGIS might be really useful for like the city of SLO or like the city of LA or something, where you've got a lot of people going out and collecting data about a lot of different types of things, and it all kind of comes back to these central repositories and servers where it can be kind of sorted and organized and visualized and all that kind of thing, right? So the power of networking all this stuff is so much greater than just like one person going out and collecting some points, bringing them back to the office, like punching them into a spreadsheet, etc. So this is clearly the future. Resources online, you can have things like data sets, this could be like shape files or point files or text or whatever. You can have web maps, services, image services, pulling down satellite imagery or aerial imagery, geoprocessing services, toolboxes, the software that is used to crunch all this data and to give you meaningful information. So, there's lots of different things that sort of exist within like WebGIS, quote. So the nice thing about this is you can kind of create workflows, and this is sort of why I encourage you to start using Model Builder, because oftentimes you want to do the same thing over and over and over again, or you want a team of people to be doing the exact same thing. So when you create a workflow, it's repeatable, it's simple, it's kind of programmatic, basically. So it's harder to screw up, essentially. Certainly can be screwed up, but it's a little bit tougher. But when you store these workflows and you store these models, you can share the model with somebody else, right? And then if you have a little bit more skills, you can actually like kind of type that into a script and try and code it out, basically, which is sort of just an advanced level of model builder. It's just taking all the model builder stuff and turning it into actual code, which is then more flexible and more transportable and more shareable and that kind of thing. So that's all good. Metadata, you probably know what metadata is. Metadata is data about data, right? And so when you have data, like say the US states or something, there's all this metadata associated with it. And sort of need to be aware of what that is and how it was created and who created it and when they created it and what it is. I will say oftentimes metadata on geospatial data is bad or it doesn't exist at all. And so oftentimes, people just don't take the time to like enter in all of these fields when they're creating their data. myself included, like I'm really bad at it just because it takes a lot of time and it doesn't really seem like there's a lot of benefit because I know what it is and I'm using it. But ultimately, like you want like downstream users to know. And obviously, this is probably less important for people like me or like you, but it's really important for like, I don't know, the federal government or the state government who is like creating all this information. And like it needs to, you need to like have the metadata about that to tell them where it is, what projection it's in, et cetera. Right. So there's this item description and all this stuff is available. You know, for all of your data that you download from the textbook data, the metadata I think is a little bit better because it has to be well documented. But like, don't be surprised if you see metadata like poorly documented. Basically, what's the purpose of it? I kind of just mentioned that. It's really just to sort of tell you what it's all about and give you the background and that kind of thing, right? Yeah, so one data for one purpose may not be suitable for another. There's no such thing as good data. I keep saying data. You're actually supposed to say data. It's data, but I use them both pretty interchangeably. But metadata really allows you to like piece back together this puzzle and try and figure out exactly where things are, and then troubleshoot things. So like if things don't look right or they're in the wrong place, or you need to contact somebody about it, like go to the metadata first. That's usually where you go. Data quality issues. There's all sorts of different issues that you might see with data. We've already talked about this. Completeness, temporal accuracy, like the time, logical consistency. Is it consistent with what we see in the real world? Attributes are like, is the table right? Positional accuracy. Maybe you're using phone GPS and not like a good GPS unit or something. Maybe it's just not in the right place where it should be. And then lineage. Where do they come from? How is it processed? Like what is the kind of history of that? Metadata standards. So there's these standards, basically all this stuff is put into these different fields. So you've got like type, tag, summary, description, credits, use limitations, all this different stuff. And all of that is sort of, it's all standardized at this point. And so we have these metadata standards basically, and this sort of allows for better sharing, right? Because if we know which fields are there and where to expect what, then it's easier to share it and then figure out what's going on, right? So we really need this really good standard, basically. Most standards require that the metadata be stored in a text, HTML, or XML format, and that's just these little teeny files that kind of go along with the data and tell you what it's all about. So which standard? We kind of have a bunch of different ones. There's a US federal standard. There's international standards. You see this ISO thing. ISO is like this organization that like quality controls things. So it makes sure that things like the quality is up to a certain standard and it can be checked, basically. We also have kind of a custom ISO standard for US and Canada, and that kind of thing. So you can import FGDC, the Federal Geographic Data Committee. You can download this kind of template, basically, and it has these standards for metadata. They basically run the metadata kind of organization, and all the standards and everything. It all goes through the FGDC, basically. They also publish a bunch of documentation and that kind of things that tell you sort of what to do, how to use it, and then you can they want you to be able to share it across platforms and across countries and that kind of thing. So this is the way that we've decided to try and standardize all this information, basically. They manage the standards for metadata. Basically, they maintain all of these standards for the United States. They make sure that things are operational across platforms, and then they give the documentation. So there are all these subcategories of what is going to be in your metadata. And like, frankly, a lot of this stuff is a little boring, but like when you really need to know certain things about data sets, it becomes very important, basically. And so I'm not going to get into exactly what it is. You can sort of read on these things if you want. But like I said, oftentimes you'll just see metadata is poorly documented and poorly reported, basically. And it's the problem that people just are rushed to do things, and metadata ends up being at the bottom of the list. Basically, it's a low priority. So don't be surprised if you see data that has bad metadata. Although if you get it from like a government agency, it should have good metadata because that's part of their job and they need to publish all that information. Basically, to give out data through certain portals like ArcGIS Online or something like that, like you actually have to fill in the metadata because they won't accept it if it's just some random Joe creating some information and throwing it out there, not telling you what it is or how it's created or why. So, so there has to be like compliance actually. And so they sort of, police this to a degree, and they make sure that everybody's like filling in all the stuff and that kind of thing. So in ArcGIS, we can view the metadata basically. And so ArcGIS stores it in kind of this internal format. You can see it in our catalog. There's different ways to view it basically, and then you can convert it and send it, to different formats basically. ArcGIS Online is cool. It's shortened to AGOL, but this is one of those things that didn't exist. Again, like when I was learning GIS, we didn't have ArcGIS Online. You just had stuff and you had shape files and you just send it to somebody else and they download the shape file and they do what they want with it. But now you've got this like cloud platform, which is great because you can share it. So if you have a group, for instance, like in this class, like you've got all these shared resources. You found some data, your group member found some data, put it into the same place. You can kind of use that as a central repository. You can share, you can do analysis. A lot of the stuff you can actually do online now, or you don't need to even do it on the desktop software. In your catalog, you can go like the portal, and there's this like catalog pane, and you can go in and you can just search stuff, right? And it's cool because this is kind of like their curated list for data that's out there, and people will submit it, and Esri will take a look and say, yeah, this is good, this is not good, and then they'll put it up and publish it, and then other people can use it, right? With different use restrictions. Like maybe you can just look at it, but you can't use it for analysis, or maybe you can just use it for whatever you want to use it for, right? Add to it, that kind of thing. But usually you need this organizational account, which you have through Cal Poly, but you'll lose as soon as you leave Cal Poly. Although if you get a GIS job, oftentimes they're using Esri software, you'll get an organizational license through that organization. But you have to basically be on the inside of Esri. And the good news is for now you are. Types of content, there's open content, that's sort of self-explanatory, that's open. Subscription content, oftentimes there's these services that you can pay for, just like a subscription kind of base model. And then oftentimes there's like premium content where you have to pay a little bit more basically. And usually like ArcGIS Online will tell you like, hey, this is gonna cost you a bunch of money to access this, so you sure you wanna do it type of thing. Delivering large volumes of data requires strategies for optimizing access speed. So when you're getting into these large data sets, they can be really weighty and it's tough. And like LiDAR is really an example because like these things got, many, many gigabytes basically. And so oftentimes they have to figure it out such that you only pull out a piece of the data that you're looking for. Like it can't show you all the LiDAR data for Los Angeles. It's going to be like a terabyte. So it could show you like a little tile basically. So what happens is that we end up like gridding these things and serving them up as tiles, like little chunks. So it's a little bit more manageable because otherwise the data volumes would be far too large basically. So that can be nice. And then also there's like this dynamic kind of scaling thing where it's like, if you're zooming in on a map, it'll start showing certain stuff, but if you zoom out, it'll actually take those things out of the map. So it doesn't crowd it and it doesn't like overload the visualization processor in your computer. So it's like, things will only start to show up when you start getting sufficiently close, that kind of thing. So there's ways to sort of control the flow of information and optimize it for that. So tiling, like I said, these are just like squares, but they don't have to be squares actually. And in fact, ecologists really like hexagons because hexagons are like almost like circles, or they're rounder than a square. And like the edge effects is a little bit different. So it ends up looking kind of like a bee's honeycomb. I actually really like using hexagonal tessellation grids for that reason. It's just like, it's a cleaner way to sample the landscape. You don't get these like kind of ugly corners and that kind of thing. So, the USGS has been doing this for years. They create these topographic quadrangles. You can download them through the USGS website, and it's just like, they're the old topo quads basically, and they're all created by hand, and they're really cool actually. Some of them are like kind of neat and historic, like people put them up on their walls and stuff. But these are all created at certain scales on a tiling scheme basically, and we still do this, and it makes sense. For the tiling schemes, like I mentioned, you can see levels of detail, and so you can like set a zoom levels. Like don't show the USGS topo quads unless you're at the scale where it would like fill the screen, for instance. Otherwise, you're just going to have a bunch on the screen if you're too zoomed out, and it'll just be like cluttered basically. So yeah, so the size of tiles, the scale at which they show, that ends up being kind of the tiling scheme basically. So ArcGIS Online, Google Earth, Bing, they all use a common tiling scheme basically across the globes that kind of uses these different zoom levels that are optimized for use and visualization, that kind of thing. So, but you can always create your own. There's 4 types of GIS services. that are served up on ArcGIS Online, and you should know these. So feature layers, so kind of think of those as your vectors, right? Your imagery layers, think of those as your rasters. Your map imagery layers, so this is kind of, these are like image tiles, but oftentimes they're based on vector data. So like OpenStreetMap is a good example of that. And then tile layers, and that's, these sit on a server somewhere, just like OpenStreetMap, for instance, and they're pre-rendered. So like they visualize quickly, basically. Oftentimes we use these for base maps, basically, because you want to know where you are in the world, basically. More GIS services. So you can create things like web maps. You can share them online. You've probably already done this for your project. You can actually create these packages, basically, which could be like a tool package, or they could have a bunch of different things in it. They could have a project and a map and a geoprocessing like tool package, and those could all kind of be like lumped together, which are kind of then portable. Scene layers are really good for three-dimensional stuff. So if you're looking like topographic things, or you using LiDAR or something that has like a really strong three-dimensional aspect, you'd use a scene layer. And then things like tables, it's just like you know what tables are, basically it's text. So for 3D services, basically you can serve up things like elevation layers, so a digital elevation model showing terrain, showing slope, showing that kind of thing. Scenes are basically they're symbolized a little bit more, and they're dynamic, so you can kind of zoom through them and kind of zoom in and out and exaggerate the tilt and that kind of thing. And then you can have these scene layers, basically, which is like a whole bunch of stuff in there, where you have things like integrated meshes, which you can create from things like LiDAR, point clouds, which is LiDAR. So like, depending on what type of data you're using, you're going to have these different kind of web layers that you'll use. A web map is kind of just as it says. It's a GIS map that really lives online, and you can take your own data and you can put it up into these web maps. You can change things on the web maps, and they're really easy to share, actually. So this is a really handy tool, and I definitely suggest that you as a group and as for your own individual projects that you do this, because this is a really great way to like share it with somebody, share it with your mom, share it with your roommates, share it with people who are in the industry or in your field that might be interested, without like telling them to go out, get ArcGIS Pro and then download all the stuff. It's like, just send them a web map. It's like a way easier way to like just share, basically. Beware. So a lot of the stuff in ArcGIS Online is really good, but not always. And so like it's kind of dealing with the Wild West a little bit. It's kind of like the there's a lot of people out there creating data, and it's not always great, basically. So you really need to pay attention to the metadata to know what you're looking at, because there's just because Esri has looked at it doesn't mean that it's great. So yeah, so just sort of be aware. Just buyer beware when you're using online data from places like ArcGIS Online. Just because it's curated by Esri doesn't mean it's good. So yeah, so oftentimes things can't be downloaded, and you'll notice this a lot when you're digging for data. You'll like find a really cool map, and you're like, how do I get this onto my like local computer and like play with it or open the table or whatever? Oftentimes like there's use restrictions from these services, and they're like, you can look at it but you can't use it, basically. And that sort of exists for a lot of different things, particularly like high resolution satellite imagery. Like, so Google Earth and Google Maps, you can see your house, you can see your car in front of your house in these images because they're so sharp, right? But you can't actually get that image because they own it, and they'll let you look at it. And if you want to pay them some money, they'll give it to you, but they're not going to offer it up freely. So oftentimes there's these kind of blocks from the service providers, basically, and they won't let you download local copies, basically. And that varies depending on who you're talking to. Ways to share data. So there's these hosted services. You can have these packages, which are a little bit more like you put all the data and the maps and the tools into a package, and you send the package, and then somebody grabs the package on the other end, kind of unpacks it, and can use all of those things in there. The hosted service sort of more lives online, and you can kind of like go pull things from it and pull them down to your local if you want. But oftentimes that comes with privilege issues and service permission, blocks and that kind of thing. So different ways to deal with these things. And it really depends on what you're trying to serve up, what you're trying to do. Within the group context, like a package makes a lot of sense. From like an organizational, like, NASA or something, they have like all of these images, like maybe a hosted services makes sense, that kind of thing. So for a hosted service, they could have all kinds of different stuff. So imagery being a good example, could be tools, could be tiles, right? Oftentimes they'll cache these tiles, meaning that they'll kind of store them, to sort of temporarily. And then they do that so that they can kind of serve them up quickly, basically. And that could be to your mobile phone, that could be to your desktop computer, that could be to like some other computer, right? That kind of thing. Packages are kind of cool because it's a nice way of packaging things up, basically, to share it with somebody else. And ArcGIS does a lot of work to like make sure these packages have everything they need and they, you know, visualize cleanly and that kind of thing. But usually not made for like a mobile device. It's more of a desktop computer, server side type of operation. Basically, when you create your maps in ArcGIS Pro, you can prepare them for data sharing. So you can kind of like create your folders, you can put all these things into it, and then you can package it up basically, and then send it. So you know, you'll and that could actually include things that are hosted online, that kind of thing. And then usually like you'll package it and you'll say, okay, check it. It'll be like a, you know, a verification kind of tool, and it'll say, actually, there's some consistency issues here, or like this layer is in the wrong projection. It's not consistent with the other ones. Are you sure you want to publish it? And you'll get like check mark, like green check mark if it's good, and like, you know, yellow exclamation point if it's like maybe questionable, and like red X if it's like bad, and like they won't let you publish things with red X's, and it'll just like bring some things to your attention. So it's a way of like kind of quality controlling what you're doing and just like helping you making sure that like these packages are cleaner, basically. So sharing best practices, there are definitely best practices for dealing with geospatial information. I'm not always great at following them. I don't think anyone really is, but there are a bunch of best practices that you should use. For one, like don't use base maps, because the base maps exist for the other person on their end. So you don't need to include them. You want to give them like an extent, a default extent where everything has that extent, or it's clipped to a certain extent, or that kind of thing. You know, keep things small, keep things simple. If there are big and complex, put them into tiling schemes, right? Change like visualization and editing parameters, you know, to meet your needs at certain scales, that kind of thing. Provide good metadata. Most people are bad at this, right? Good tags, like the tags are things that you can search things by. So it's like you want to, you know, make a file about the colleges in Oregon. You know, you have to like put tags, colleges, Oregon, community college, university, student, etc. You like put all these tags in there, and that way if somebody's like trying to find it, then they can, you know, if it's got good tags, they got a better chance of finding it, basically. So anyway, yeah. So selecting cache scales, caching, like I said, so your computer does this all the time, and it's really important for GIS stuff, but it's basically like holding the information like locally and being like ready to serve it up. And sort of mention that, you know, that this sort of exists within a lot of these online services, because they don't want you sitting there waiting for it to load, basically. Mobile applications. So on your phone, you can get ArcGIS Pros, or sorry, it's called Esri Collector, and there's another one called Survey 123, and I think there's like a new one now too. And then there's like Q Collect. There's like a couple like open source ones too. It's very similar. And you can like Bluetooth to like a really high accuracy GPS and get like really, really precise points, or you can just use your phone GPS, which kind of sucks, but it's still like better than nothing. And you can go out and you can collect points, lines, polygons, you can make notes, you can take pictures, you can take voice recordings, like you can do all these things that are then like geospatially referenced, and you can put them into your online map. And this is like what the base map team and the base map project at Cal Poly is kind of doing. They're like going out and verifying these things, take pictures of them, you know, put them into the web map, and then kind of crowdsource that activity, basically. So, you know, just sort of be aware of that. A lot of this comes down to mobile data collection, right? This is the type of thing, like, you know, when I was in college, I didn't even have a smartphone. And now we have like these little beautiful computers that can do all of this stuff. And so you can imagine how powerful it would be to have like a team of people with these phones that are, you know, GPS enabled, and they can all feed into like the centralized web map and that kind of thing. You know, oftentimes there's a lot of setup on the front end to like set up these feature classes and make sure they have all the right fields for like photos, and, you know, like it has to have the right architecture, and maybe make some notes about who's collecting and all that stuff. Like, it's all like front end stuff that you have to do before you actually get out into the field. But once you get out in the field, and if everything's, you know, configured well, this can go really, really smoothly. You can collect a lot of data really fast. So yeah, it's fun actually when you see like a bunch of people going out at once and like populating the same map. It's actually really neat, because it's like you just see data coming from all these places, and just like the map grows really, really fast, which is kind of a satisfying thing to see. So domains for mobile collection, there's all these different things. And so you might actually want to code your responses. So like, you know, so you go out and collect information about like surface materials. You don't want somebody like typing in concrete every time. So you like have these categories that are already in the feature class. It's like a drop down menu. So it's like, okay, this is concrete, asphalt, gravel, dirt, whatever. And those are already like pre-coded in there. So you can create these things called domains, which are essentially just this. And it's really recommended that you do this, because then, like, if you don't capitalize one or you like misspell it or something, then it'll like the computer will see it as a different category. So when these things are like pre-categorized into domains, then there's less chance for that kind of screw up, basically. So steps to collect mobile collection, there's a bunch. Usually what I end up doing is actually just Google 5 minutes to your first Esri collector map. And somebody like created a little blog post, and it's like, it really is like 5 to 10 minutes to create a little thing, to get a little map on your phone and go out and collect data. It's really quite easy now. So yeah, it's kind of nice, but this can be extremely complex, and you can imagine, for like a city or something who's trying to collect all these different data points as their workers go out in the field, this can get way, way more complex. Most of the time people just want to take a point or two with a couple different attributes about it, and that's really it. But at least in the student context, this is relatively simple. One thing I always like to say is, like, for mobile devices in particular, and web maps as well, like a good web map is a simple web map. And for mobile devices in particular, like, simplicity is key, because you really only try to tell a couple things. Maybe show a base map, maybe show where you are, and then like when you collect, your point lines or polygons, make them big, make them bold, make them stand out, and don't put too much into it. Basically, the more complex you make a web map or a mobile map in particular, the harder it gets to use, basically. So KISS principle, right? Keep it simple, stupid. That's what my dad always used to tell me. Sharing workflows. Okay, lots of different ways to share workflows. The most popular, especially for intro users, is Model Builder. QGIS has a very similar tool. The next step up from Model Builder, and I always call this like the gateway drug into scripting. This is how I got into like coding, is using Model Builder, but then like taking the Model Builder scripts and, taking the code behind the Model Builder models and then exporting them to Python, and then using that and actually writing your own script, basically. Tasks, basically they're workflows that can allow people to make decisions, interact with these workflows as necessary, change them, that kind of thing. So right now we're sort of dealing in like the Model Builder mode, and if you've got any sort of coding skills, or you're curious about it, you're a little code curious, you should get into the scripts. And it's really quite easy to go from a Model Builder model to a Python script. Like when you run a Model Builder model, it has all the Python code that the computer's running, basically. The problem is it's all like hard coded. So it's just saying like, oh, you have a shapefile, it's on your C drive here. But like maybe you want to make it so that it's flexible and it can do it for like any amount of shapefiles, or like all of the shapefiles in this one folder, that kind of thing. So you have to make some little tweaks and that kind of thing, but you can actually make those Model Builder models really flexible and really powerful using scripting, basically. So can't really harp on that enough. Model Builder, it's really nice because it's like, this is coding for dummies, basically. It's like you got your blue things, which are your data sets, and then you got your yellow boxes, and that's your tool, and then you got your green, circles, and that's your outputs, and that kind of thing. So they like visually it's quite easy, and then you also see the flow of like, this happens first, it goes to this other one, then this happens, and it goes to this third thing. So like the visual flow of it is actually quite nice, especially for visual people who kind of can use this type of thing. So why use Model Builder? I sort of just mentioned it. It's simple and it's repeatable. That's the biggest thing, and it's portable. So, so you can allow these workflows to be shared with others and that kind of thing. It's a great way to share the analysis step of GIS. Models as tools. So you can create models that have a bunch of tools in them, and then you can create just like your own standalone tool that has all of these, these things kind of baked into it. And you can create parameters. So like you need this parameter as an input parameter, you need this other parameter for this tool to work. And if you have these two things, then the tool will work and it'll spit you out whatever sort of output it is that you desired. Scripting within a GIS context, especially now, it's all done in Python. Used to be like in Visual Basic or like one of these old languages that not many people use anymore. But now it's all in Python, and a lot of people use Python, not just in GIS, but across data science, and just like a lot of coders use Python. It's just a really kind of user-friendly language. And a lot of them, the GIS side of it, they'll call these GIS tools that aren't necessarily written in Python, but like, maybe they're a C++ package or whatever, and it's just calling the tool, and the tool does the thing, and it gives you the output. And in a script, you're really just like calling the tools, just like you would run the tools in a toolbox in your ArcGIS Online thing. It's just doing it with a line of text, Python code, as opposed to like clicking the GUI, the graphical user interface, and putting in the different layers and getting out your outputs, basically. So the nice thing about programming is that you can be more flexible. It's easier to share, and it's easier to repeat things. So when you find yourself doing the same tool over and over and over again, it's like, ding, like I should be scripting this, or at least putting it into a model, because it's way easier to like click the model or run an iterator in the model, or write like a for loop basically in a script, and then you can do, you know, a tool an infinite amount of times basically. Tasks, you know, this is kind of this interactive workflow. Frankly, I don't use tasks very often, but maybe that's because I don't understand them all that well. But I've heard that these can be really handy, basically to kind of, you know, categorize and sort of, you know, create a flow on, like, you know, you have a very specific workflow and it'll do a bunch of different things. So these tasks can kind of help you like launch one step of it. Once that finishes, you launch the second step, etc. So there's this thing called the task designer basically, and you know, you give it instructions, you kind of have to like, you know, describe what's going on there, that kind of thing. And so, you know, you have these tools and you give it commands, and then it gives you an output basically. So something that you might want to look at if you've got to do the same thing over and over and over again. All right, so that was all the textbook stuff. I'll briefly go into a couple other things I think you should know about. Make sure you're focusing on your projects. Have little hack sessions where everybody's working together. It doesn't need to be during synchronous time. It could be during, you know, whatever time is good for people in your group. I would recommend not making single people responsible for single tasks, because if one task gets hard and one person can't finish it, and like other people are dependent on that, it can like screw up the whole workflow. So I would say, you know, you could still have a point person on it. Say if you have a task, this person is in charge of it, this person's maybe going to help them, that kind of thing. And then have a big task list, running task list, keep each other accountable, have internal deadlines, meet bi-weekly. You know, weekly is good, but we don't have that many weeks left. So I would say meet bi-weekly, or at least keep in touch with each other on Slack, send each other messages, you know, and then bring something visual to show during these conference calls. Bring something like a map, web map, something to like share with each other as you're visualizing these things in your Zoom calls. So WebGIS, like I said, is kind of where things are going, right? This WebGIS can be like this front-facing, public, you know, facing kind of GIS that could be operation system independent. You could use a Mac, you could use a Linux machine, that kind of thing. Desktop GIS as we know it is sort of, it's slowly being phased out. I mean, ArcGIS Pro is going to be around for a long time, and a lot of people just like having it locally. I'm definitely one of these people that like to have it on my local machine, but we know that things are heading this direction. LBS, location-based services, is a huge part of WebGIS and sharing GIS right now. You probably know about this through a bunch of your apps, right? All of, like, so many of your apps are asking, can we share, you know, can we use your location? PlantStat, iNaturalist, Uber, Lyft, right? Instacart, Instagram, Tinder, Grindr, right? Like all of these are apps where it's like, you know, your location is really important. When I was in grad school, I actually got recruited to work for Grindr in West Hollywood. And I was like, and the recruiter was like, it's a huge app, like 100 million users worldwide. I'm like, I've probably heard of it, like, but they wouldn't tell me what it was. And eventually, like, they kind of had to tell me. So I'm like, what is the company, right? And they're like, it's Grindr. Oh, okay, interesting. So I could use my geospatial Python skills to, you know, help users of Grindr. Basically, I didn't take that job, but it's still kind of interesting to me. Location is obviously super important. Here's a web map. Here's something you've probably seen a bunch of times. This is the Johns Hopkins COVID dashboard. This was from this class last year, and I just wanted to show it because this is what we were at this time last year. About 3 million cases worldwide, 211,000 deaths. And this was from when this lecture was recorded, about 3.2 million deaths, 150 million cases worldwide. So, and that's something. Okay, Google Earth is WebGIS. This is just kind of, you know, this is all this stuff on the web, and Google Earth allows you to access all this stuff on the web. It doesn't allow you to download a lot of it, but you can see it, you can play with it, you can add to it, but it's kind of closed in some ways, right? So this is probably one of your first touches with WebGIS, like Google Earth and Google Maps, basically. Google Earth Engine, I mentioned this in the last lecture. I think this is really a cool platform where you don't bring the data to the problem, you bring the problem to the data. Google hosts all the data in their big data lake, you know, 45 petabytes of data or whatever it is, and you bring a question and it says, okay, give me a second, I'm going to go into the cloud, query all this stuff, like do what you're asking me to do, and then spit you back a result. And you can do that, you know, on a tiny little web book. You don't need any processing power really almost to send those queries up, basically. Because you can't download the entire Landsat archive or Sentinel archive, right? It just doesn't work. So you do need to know a little bit of code, a little bit of Python, or a little bit of JavaScript to access Google Earth Engine, but totally worth it if you want to do large and especially like temporal type analysis, like long time series, that kind of thing. You can look at these. This is a video here you can check out. There's a link to it. It's kind of cool. It just shows you like some of the stuff you can do with it. Google Maps is WebGIS, right? It's very targeted at specific things that you're trying to do, but this is very much WebGIS. Waze, created by like an Israeli geospatial analyst, like GIS analyst, actually. He did this like on his free time, created Waze, which is basically crowdsourcing, saying there's a speed trap here, like this street is closed, whatever. All that stuff gets put up into this map. You get like imaginary internet points, and it helps the map. It helps people navigate better, that kind of thing. You've probably seen your Uber driver with like Google Maps up on one or the Uber app, and then like Waze up on the other, right? But I think the guy who created Waze sold it for about $1 billion to Google. And it's funny because Google uses some of that crowdsourcing data, but not all of it. So like they let Waze sort of exist on its own. They take some of that data into Google Maps and they use some of it. But they make decisions about that, which I think is quite interesting. Strava, you may have heard of this. Strava is like this, cyclists use it, and like runners and stuff, and they just, connects to their phone, their iWatch or whatever, and it just like, go on a run, right? And then like outlines it. But what happens is they put these together, these heat maps, and what it showed up was like these like dark sites, like these like military sites that like aren't technically supposed to exist, but like all of the soldiers are like getting out and going for a run. They just like run the perimeter of their base or whatever, and it like shows up on the Strava map, and it's like everyone's like, what is that place out in the middle of Afghanistan? Like, oh, that's actually a CIA base or something like that. Like, ooh, gonna have to take that one down, right? WebGIS is an extension of your mental map. So like you have a mental map, and I always like tell my mom and dad, my wife, it's like anytime you get like someone's address, save it in your Google Maps, this little pin, right? Because then it's like, I know roughly like where my friend lives on that side of town. I only have one friend over in that side of town, right? And so like if I zoom in to that side of town, it's like I can find their pin and go there, right? You'll notice in this map, like I got like these like fishing spots that I like to go. Like I caught like a big fish, like on my kayak. I'm like, oh sweet, this is a good spot. Like drop a little pin, right? So I can come back there later or that kind of thing. So it's just like a really nice way to sort of, kind of organize all that information. I really like using this for restaurants. So like go to a good restaurant. It's like, oh, I found this cool Thai place in like Portland, like awesome. But like, I'm not gonna remember the name of it, but I can remember where it is. So I just like all my maps, they're like full of these pins. When I find something cool I want to come back to, I just drop a pin. So it's your mental map. It helps your brain store information and get back to it, right? It like maddens me to no end when people are like, hey, what's your address again? They've already asked you like 5 times and they've been to your house. It's just like, dude, just drop a pin on your map and save it, you idiot. Anyway, sorry. Leaflet and CartoDB, these are 2 open source JavaScript libraries. I guess Carto is in Ruby as well, but they're software that are designed for web mapping, and they're open source. So like there are these little packages, and you can like access Leaflet through like R and call it from these different places, but they've got all these different plugins, so you can have like your geospatial information, you can embed it into websites and that kind of thing. So these are really, really great packages for that kind of thing, basically. Coding for WebGIS, you pretty much need to learn how to code to do this at a high level. So we're talking about JavaScript, Python, HTML, SQL, all that kind of stuff. A lot of the coding is getting easier, so the barrier to entry is getting lower progressively, but definitely encourage you to get into these skills. Even if you're a liberal arts major and you're just like scared of code, you don't have to learn a lot. You just need to kind of learn the basics, right? To at least be able to speak the language to talk to developers and that kind of thing. So really important to know this kind of stuff. And I learned this lesson too late, frankly. Like I didn't pay attention to any of the coding stuff when I was an undergrad, and I had to learn it when I was a PhD student, and it was like way harder. So don't be afraid of it. Be open to it. So that's what I'm saying. You guys know about SQL, PostgreSQL, or PostGIS, as it's now called, is an open source kind of SQL, spatial SQL, and it's called PostGIS. This is great. A lot of companies are starting to use this because they realize they don't need Esri as much anymore. But you can, write SQL queries, but it deals with spatial data much better than traditional platforms. Mobile GIS, again, this is your phone, right? This is your tablet, that kind of thing, but this could look in a bunch of different ways, right? mobile GIS is kind of this like umbrella term for like anything that's spatial on your phone, basically. So I don't know, I think it's kind of interesting. This is a cool video I just saw on CNN, and this is basically using devices to track and do contact tracing, or just like hotspot analysis for COVID-19. This is from last year, like when the pandemic was just starting, but it was really interesting because people were still going like spring break, woo, and it was just like everyone goes like Miami Beach and like they just take COVID like across the, across the country, that kind of thing, and using phone data. Now that idea freaks people out a lot, and I understand that. But so there's a lot of like privacy issues that are kind of tied up in this. But with something like COVID, it's kind of important to know, basically. Location is relevant to nearly all mobile applications, not all, but like so many of the apps that you use, they want your location because it matters for, what you're shopping for or the ride you're trying to hail or whatever. So like, and that location chip in your phone is like really, really integral to like so many mobile applications, basically. Indoor GIS, integrating the Internet of Things, IoT, with sensors and building information models and all this kind of stuff. So GIS is moving inside, basically. And when we move inside, we got all kinds of stuff that we're contending with, like Wi-Fi and cameras and security and emergency systems, and all these things are wired, and now increasingly they're connected to the internet. And so we're merging the worlds of GIS and CAD and IoT and all these things come together. And like the common kind of hub on this is the internet, where all of this information is sort of being shared, basically. Any sort of real-time tracking or navigation, all of this has to be obviously beamed up through the internet to share out to whatever repository that all that data is being served up at. But like anything that's real time, it obviously is using the internet, sharing location. Self-driving cars, obviously critical to have an internet connection to know about things like road closures or lane closures or things like this, where you have to tell the car that's like going down this highway, like things are different up there than they normally are, like be aware. Git is something that some of you who start to code will, or that already do code, are well aware of. Basically, it's a way to collaborate on code. So you'll have like a master branch of like a tree, for instance, and then like you go off, you have a branch and you work on it, and then you can like rejoin it to the main branch, and another collaborator can do the same thing. It's a really handy tool, actually. So it's a way of doing like what's called version control. So you're not like doing code underscore v2 or v3, like which one was that, which one are we using again, right? Git is a way to like streamline all of that so you don't have those big issues. GeoNet and Stack Exchange, great places to go to steal code and post ideas and questions and that kind of thing. So really copying and pasting is good practice, actually, in coding, right? Crowdsourcing the problem, get the problem out there, have somebody else help you with it. This is actually not relevant, but story maps is. So with story maps, please create one of these for your project. It's a great way to share GIS with people who are not GIS savvy. It's essentially a website, right? But with maps embedded into it, your own spatial data embedded into it, imagery, videos, all these kind of cool things. So this is like a nice way to like wrap up your kind of your projects, basically, put a little bow on them. So start creating a story map, and that's all I really have for this lecture. So I'll stop sharing my screen, and with that, I'll say thank you, and I'll see you soon. All right.